Hello, in this list I'm going to present a simulation model, a Simio model, to analyze the funnel case for which I previously created a different playlist. So I recommend uh, to watch that list first if you haven't done it, and then watch the following videos. So remember that we have a process, which is the one where we had buyers entering the process and valves being shipped to customers, where we have a set of steps in which we do that transformation. And we have an early production at the beginning, or we have a productivity. And there's this company, Funnel, which produces these valves, that wants to improve it. And they have a budget of 1 million euros, and they can spend it or invest it, to be more accurate, in the different processes. And we have different costs for each of the things they can do. And we have a some of those improvements they can do listed in this table here, but they could do more. And the objective is to use a simulation model or to analyze how they can do that, and we will see that a simulation model will help us do that. And we can do that in several ways. We could just experiment with the real system. We can do just some investments and see what happens. But this is a very bad idea because it's very risky. We don't know the outcome of our investment, but we can use some rule of thumb or we can use our intuition, and it's risky anyways, but because we do not know what will happen in the future. It's very slow, obviously, because we will know the results when 1 year, 2 years have passed. And it's not replicable. We cannot just go back in time, make another decision, and see what had happened. So we have just one go, and because we cannot just decide investing or changing the layout of our plant every month. It's something very costly, and you have you have one chance to do or whatever you're going to do and see what happens. So it's not a good idea. The next thing that we can do is to do some Excel analysis, intensive but basic though, which would consist in doing what we might call a static analysis. For example, we have the saw, okay, where we have a lot size of 3, a cycle time of 6 minutes, okay, that would give us a maximum production rate of 30 units per hour. If we discount the breakdowns, we might estimate a production rate of 24. Okay, so we can do that for every single process in our system, and that would give us an idea of where our bottleneck is. And we can decide based on those numbers where is worth investing. But that is not very accurate, and again, it's risky and still useless because we do not see the effect of the interconnection of the different processes because there are buffers between some of those, and sometimes you don't have enough buffer. So you cannot foresee what is the impact of improving what is supposed to be the bottleneck of your system and how that goes downwards and how that impacts the production eventually of your system. So that's why we think it's not a good idea to do that. And the final option is to do some thorough or some systematic analysis using, in this case, a simulation model. There are many techniques you can use for analyzing complex systems, and in this case, simulation is a very, very good option. I have a playlist on simulation, another one on optimization, as introductions to these two topics. You can watch them and decide when is best to use one or the other. And what we are doing is something similar to this video we have here. Okay. I want to reproduce it. There you go. This is a model or a video from a model that was created by someone in the Simio company. And what we see here is a nice 3D representation of a system, but the value is not the 3D. it's easy to build that 3D layout because you can see how things are similarly to how they would be in your real system. But the important thing is that you have forklifts, you have conveyors, you have cranes and different things in your system, no matter what kind of system you're dealing with. And you decide, you configure every single element as they would behave in the real world system. And you can tune, you can change how these elements behave and see what is the expected results. Okay, so this is a nice model, but what we are going to do is something like this. We have, remember this layout we explained in the other playlist, and what I have done is I have created a Simio model where you can see the resemblance between what we had in this image and what we will see in our simulation model. And what we are going to do is to experiment with the model.